Now I'd like to demonstrate some techniques that you can use to first begin with a binary pattern expressed in a number of different ways. You can put these together as a single array, you can interpret them as numerical values, and you can pull out various bits and pieces of the Boolean values as well. I'll begin by creating a few individual Boolean controls here. And when I do the copy operation there, you simply hold down the Shift button first and then click on the item of interest and drag the copy away. So I've got two Boolean controls, and here I'm setting up a Boolean array as a control. Now the discrete Boolean sources, like the controls that I've placed already, these are common for the FPGA input pins that you would be working with later on. Certain sub-VIs might be producing a Boolean array, so that's why I'm using that as a control as well. And of course we can set up some Boolean constants as sources of Boolean information. And lastly, if we have a numerical value, it's easy to translate that into its associated Boolean pattern as well. I'd like to set this up, or set up this control so that I can type in a hexadecimal value, and then it's also nice to alert the user to the fact that the control is in fact expecting a hex value. So the numerical value can easily be converted to a Boolean array. Then all of these Boolean sources can be easily combined into a single array, as I'm showing here. The build array node operates such that its LSB is on the top and the MSB side, or most significant bit, is on the bottom. You'll see the build array node can easily accommodate mixtures of individual Boolean signals as well as array type signals. And if you're familiar with the concatenate operation in languages such as VHDL and Verilog, then the build array would be the equivalent of that concatenation. I'd like to take just a quick look to make sure that things are making sense here. So as I start putting in different values for that 8-bit result coming out of the numerical display, we can see that in fact the upper 8 bits are all set or active when we put in FF, or hexadecimal FF. Alright, this is working out pretty well so far. Next, I'd like to show how you can now extract some values from this Boolean array. We have to do a two-step procedure here. First, we convert it to, or convert the array data type to a cluster data type, and that's that pink thick wire in the middle there. And then I can use the unbundle by name, and I can expand this as much as I need to. Although you'll notice at some point it seems like it rails out at the value 8. If you just want to pick off a few number of bits, you can then select the bits of interest. But at some point you say, well, how do I get at these upper bits that are associated with the array. Looks like if I do my count accurately here, we have a total of 14 bits in our array. So I can change the cluster size that's being generated here. And now, in fact, we can get at any bit that we need. So I'll go ahead and create a couple indicators here, and you'll notice that some individual Boolean indicators are showing up around the front panel. And I'll copy this one so that I can also demonstrate that you can pull off different numbers of bits if you like. In this case, supposing I just wanted to set up a subrange of the first 3 bits on the LSB side. So I want bits 0, 1, and 2. I can pull off those bits and then use the build array node again to assemble those back into, in this case, it would be a 3-bit Boolean array. And I'll, just for fun, convert that back to a numerical presentation. And we should be able to observe that no matter what patterns we select, that numerical value is somewhere between 0 and 7. All right, let me first reinitialize the values back to their default settings. And again, if we observe carefully here, we see that, again, realizing the LSB is on the far left, that would be 5. Now, notice that when I did the reinitialize, we lost some of our Boolean controls there. And in fact, those are missing at the moment. So as I select a specific value, either true or false, we then see that those are starting to fill in their accustomed place in the larger array. This is a consequence of the array or Boolean array control having an undefined width. So you can really add or take away elements as needed. So I'm just pointing out here that as you look at just those lower 3 bits there, bits 0, 1, and 2, that sure enough the numerical interpretation makes sense. Now, an alternative method for picking off a subrange involves the array, what's called the array subset node. Here I simply say, here's the first index that I need from the array, and then I specify the number of elements that I need. So we pull these off all in a sequential order. The earlier method that I showed you, which is just above where my cursor is right now, that has the advantage that if you can pull out arbitrary bits if you should need to do that.